Chapter 34, question number 5. A bar magnet drops through a wire loop. Which graph and figure best shows how the current through the wire loop varies with time? Assume that a negative current refers to a current flowing in the reverse direction. And this is the figure 3421, and this here the current in one direction and the current in the reverse direction. There is possibility of option A, B and D, not this one. Because there is no negative current here, it means that it's not showing the reverse direction of the current. Let's consider the situation in which through a wire loop a bar magnet was passing. We know that when the magnet is approaching toward this wire loop, then current will induce in this circular wire, but the direction of current would be such that it will oppose the magnetic field due to this magnet, because from Lenz's law we know that induced EMF or induced current are such that they oppose the cause that is creating them. The south pole of the magnet is in this direction, so the current through this wire will be such that it will create the south pole upward and north pole downward. So from right hand rule we can see that the current will flow in clockwise direction, then it will oppose the magnetic field of this one. So let's suppose the situation like this or like this could be here. This bar magnet is passing through this wire loop. As we know that when north is above and south is below, then the flux that is entering through this wire loop is exactly equal to the flux that is leaving through this loop. So it means that there is no current flowing at this time. After that, when the bar magnet is finally passed through this loop, then we have north here and south here. So as the bar magnet is receding away from this current loop, so it will induce a current in a direction just to support the magnetic field, because the magnet is receding away from the coil and the induced current doesn't like the change. So in this situation here, at the bottom south pole is required and at the top north pole is required. South pole will attract to the north, so the current in anti-clockwise direction will flow in order to support the magnetic field of this magnet, bar magnet. So option A is the correct option. This option is incorrect because here not for instant of time the current is 0, but we know that when the bar magnet is in the middle of the circular loop, then the flux leaving the wire exactly equal to the flux entering the wire. So here the current for a certain instant is 0. That's why this could not be the option, so option A is the correct. Question number 7 is the long straight wire in figure 3423 carries a constant current I to the right. What is the direction of the induced current in the wire loop? Clockwise, anti-clockwise, or there is no induced current? As it is given that the current is constant and it's in the right direction, at the circular loop is neither moving nor this wire loop is moving, so it means that the flux that is passing through this circular loop is constant. So due to constant magnetic flux there is no current in the wire. That's why option C is the correct option. Question number 8 is the long straight wire in figure 3423 carries a current I to the right that increases with time. What is the direction of the induced current in the wire loop? Clockwise, counterclockwise, or there is no induced current? So there is again figure 3423, but this time the situation is the current increases with time. This is the situation in which I is increasing with time, so flux is changing. So if the current is in right direction, so from right hand rule we can see that at the top of this wire the current is outward and at the bottom of this wire the current is inward. As the I is changing, so it means that the magnetic flux is changing with time. So change in flux basically induces an EMF in this coil, and so as the current. So the direction of current will be such that it will oppose the growth of the magnetic field. If the external magnetic field due to this wire is out of the paper, then the current will flow from this wire in clockwise in direction in order to stop that increase in magnetic field. From right hand rule we know that if the current is moving in clockwise direction, then the direction of magnetic field will be inward, that will oppose the external magnetic field of this wire loop. So for such situation the clockwise current will flow in the wire. Question number 9 is the long straight wire in figure 3423, again the same figure, carries a current I to the right that decreases linearly with time. At time tr, the current is 0 and then begins to increase linearly in the other direction. What is the direction of the induced current in the while loop? Options are clockwise, counterclockwise. The induced current starts off in one direction, but at time t or it stops and then begins flowing in the other direction. There is no induced current. It is given in the question that current in both situations the current was to flow in the same direction. Then option C might be the correct option. But it is given that at time tr, when the current is 0, then after that it is increasing linearly in other direction. It's also increasing, and also the direction of the current is reverses. Here we can see that the magnetic field is out of the paper but decreases with time. The current in this wire loop will be such that it will support the external magnetic field of this wire loop. That's why anti-clockwise current will flow such that it will generate a magnetic field out of the paper like this. After that it was given that the current would be 0 and then it will changes its direction, means it will flow now in the leftward direction. This current is increasing. Here if the current is in the right direction, so the magnetic field would be into the paper. So we will show here with the cross. The magnetic field is inward and as well as it's increasing. So just to stop an increased magnetic field inward, the induced current in this while loop would be anti-clockwise. Magnetic field due to this loop would be out of the paper, that will oppose the growth of magnetic field inward. So in both situations we can see that the current is counterclockwise. That's why option B is the correct option. Next question is the long straight wire in figure 3424 carries a current I to the right that increases with time. What is the direction of the induced current in the circular while loop which lies in the plane perpendicular to the wire? Clockwise as viewed from the right, counterclockwise as viewed from the left, or there is no induced current. As the increasing current of this wire is passing through this circular coil, so the flux that is entering is exactly equal to the flux that is leaving, so there is no induced current, neither from right or left, neither clockwise nor anti-clockwise. There is no induced current in this circular coil.